you very much. Appreciate you making time for us today. As discussed earlier, yesterday was a technical issue, and we'd like to be able to present to you because we think we bring a lot of value to technical publications as used in a number of areas. So based on training manuals, troubleshooting routines, assembly instructions, pretty much any procedure that you can flowchart, they're all examples of ways the technical, or the military and commercial sectors use technical publications. Simply, a technical publication is a way to transfer concise information to a common source or a wider audience. TechPubs should not be open to interpretation. This is not a bedside novel. They should be concise and informative. We'd all agree that the examples shown here are technical publications, but the illustration here is based on 60 years of disparate information. So some of those technical publications are recent, some are almost 60 years old, and they're very similar, and we all interact with them the same way. We read them, and we take the information in, and we have to project mentally, based on the figures and illustrations, how that use would actually happen. So while we all think that because of the call-outs and the specific direction noted here, these are technical publications. But are these technical publications? I think that the information is specific and concise. There is no level of interpretation needed. So I think that based on the information on the page, yes, just because they don't have all the wording and the call-outs doesn't make them any less informative. So the evolution of TechPubs has been directly correlated to the products they're relating. So if you have a function of a product that was first developed years ago, the technical publication started out handwritten and then went to a printing press. Obviously, today we take the 3D data from the CAD and flatten them into 2D drawings. That data can be updated based on your PLM or your lifecycle management in your CAD data. But what if we took that a step further and we actually utilize the CAD data itself to create the technical publication rather than flattening it into 2D? I think it's about time we utilize this. The data behind the products we are translating the use of is every bit as flexible and fluid as the technical publications should be. We started out with wooden models to protect a prototype. Then we came into CAD data and automatic updating through sections in the CAD data. I mean, all this development is not been translated into the end user. So in today's CAD and tomorrow's CAD, we're actually going to be able to let the end user interact with the product before the first prototype is ever conceived. Now, how they interact with it is a different story. So I think we've all used 3D by now in our daily lives. I think if you've been car shopping lately and gone to an interactive website from an auto manufacturer, you've more than likely played with the build simulator and been able to rotate around the vehicle in 3 dimensions. Although this interface is a little flat, you may not have been able to zoom in and find detail, and you may have been you're limited to the number of options they predetermine you can view the vehicle from. On the other side of that is completely immersive virtual reality. So while that requires a good deal of setup, some virtual reality goggles, and maybe some earphones to provide the right ambiance, it's all the equipment and the location-specific needs are maybe a bit too intensive for typical training routines. But I think there's a pioneer out there in the commercial market, and the things that we're looking at is a middle ground between those two other experiences. On the right, you see a product from Crayola aimed at 6 to 10-year-olds called Color Wonder. And this is fantastic. If you are able to go to their website, download an iPhone or an iPad app, you can print out on your home computer pages for your children to color. You take the app on your iPad, point it at the page, and the image comes to life in 3D, and they're able to interact with it. This is a development that has come on the market parallel to our development in the training sector, and I think it's very applicable. And I think it also paves a little bit of a precedent for how to interact with 3D on a very mobile and personal level, without going all the way to the goggles and without having that flat experience from building your own automobile. The tablet on mobile devices in your pocket have enough computing power now to handle large amounts of 3D data, and everybody knows how to use them. So we can take that device, and as you'll see in the video immediately following, you'll be able to, from the very first time, walk through very complicated procedures. Now, this video does show another step in the realism called augmented reality that we've built into our training platforms, and you'll see it at in the last shot in the video, how this brings the user into the training environment. So I hope you understood that airplane, although it is a physical commodity, you can go out to Target and buy them off the shelves. In that video, the airplane was not a real object. It was projected by the processors onto the image located in the camera and the mobile device. So that was a screen grab off of my telephone, and I'd be happy to run through that interaction with you later. If we can switch over. So I have a live interactive video, or live interaction, I should say, that is a demo of our software I'd like to run through with you. And forgive the appearance, it's a bit rough. I would call this a beta demo, but we wanted to get it in front of an audience to show the functionality, I think from a user standpoint, really have the flow as it should be. Go ahead. Can we flip over to this one? Let's just make sure we have a feed. This will be tough to do if I turn my laptop around. Should be. I'm still seeing your screen up here. Yes. There we go. All right. So in a typical training document, a technical application for a repair or replace procedure, you'd go through some steps that will be illustrated later. But here in our interactive environment on a mobile device, we want to make sure that these aren't in the wrong hands. So obviously we have a login routine. Because of the mobile device camera, we can always do a login scan. Just scan your ID through the camera. But here we're going to and just hit. The next screen would be a vehicle identification screen. Depending on what you're working on, you may go and choose a specific vehicle off the floor. In this case, we've worked up the vehicle operation for ground vehicles. But let's say you have a vehicle from manufacturer B with a certain number of options on it to identify a specific vehicle, or you can enter a VIN number. Scan the VIN number with the camera, or simply scan the barcode on the vehicle. Most vehicles, at least in the commercial sector, are barcoded these days. So either of these options would work, and we're going to do some maintenance on that vehicle. Now, This is all if the user would choose to do it themselves. In a typical routine, you'd be emailed a package in which the app would begin at this screen. So you could choose which procedures you'd like to do. Our display's a little off. I'm going to choose a shock absorber replacement that you can't see out there. I apologize. But as in the training manuals, you'll be run through some upfront verification. Did you pick up all the tools from the crib? In this case, a general toolkit and a wrench, torque wrench specifically. So acknowledge that. And then all the things, the materials and expendables that you might need, including your gloves, goggles, and expendable lock nuts. And acknowledge that. Here, the condition of the equipment. Have we set the transmission to neutral? Yes. Did we set the parking brake? And is the engine off? And then finally, the main power switch, wheels chocked, and the engine armor plate. Acknowledge. So that would set us up. Here we're looking at our entire vehicle, and note the orientation of the shock absorber that we're focused on to ensure proper installation. Now this is a typical instruction that you would find in the 2D, but here we're going to run you through the procedure, and the first step is to remove the bolt. So we've got this bolt, and the entire assembly represented in three-dimensional data. So you're welcome to come in here and change the position of that. I'm not really sure where it came from. Well, let's go back and replay it and see it all happen real time. The next several procedures or steps in the procedure would follow. Your camera view does change to follow the action, exactly what's going on. So in this case, if you've managed to choose a camera view that locks you out, we can go back to the previous procedure, step through again, and rotate around manually to find that screw. Now, as we step through these, obviously the procedure is very rudimentary, but this can be applied to just about any level of technicality. Once the shock absorber is removed, we see a warning about the anti-seize compound we're about to apply. So we're in the acknowledgement. Because the acknowledgement was under my user ID, I've accepted full responsibility for the safety protocols associated with that. And now we can begin reassembly. Now again, at any time, I can choose to rotate around, refine my view, zoom in and out on the product as necessary. At the end of the task, I can hit an acknowledgement button, and that lets my CO know that I've finished the task. It also lets the appropriate back office procedures happen, including reorganizing and reordering the parts from the tool crib. So let's say I do a brake caliper replacement. Similar situation where we acknowledge all the conditions, including the special tools needed. Yes, I've acquired all these from the crib. I've gone to the parts depot and acquired this package, and then gone through my procedures, including engine off and main power, wheels chocked, and oh, by the way, there's front brake pads to be removed before we do this. Any of these procedures, once they're in the system, can be live. So if I've forgotten to remove the brake pads, for instance, I can click on that, and it asks me if I'd like to go through that procedure. In this case, I'm pretty confident I can do that on the fly. So I'll acknowledge that all my preconditions have met, and go back to a full vehicle view so that we can orient ourselves to the area we're working on. So using a ratchet adapter and screwdriver, I'm going to remove the front brake caliper assembly. I apologize, those instructions are off screen as you see them. Then we're going to go through and remove the caliper itself. Another warning for brake dust and anti-seize to make sure that we understand the responsibility around those toxic issues, and then come back and reassemble the caliper. The attachment bolt, and notice there are no pads in this caliper, it's completely empty. Now at the end of the task, assuming we've gone through that pad removal routine, it would direct us to then reinstall the brake pads. Because I skipped it, here we're going right to the end and back to the home page. All right. So while this vehicle and these procedures is a mishmash of made-up instances, I think that it's fair to see that this can be applicable to a number of operational training issues. If you spend an enormous amount of training up front, this can reduce your upfront training and be translated into first use, understanding of the procedures. All right. Have any questions before we move on? Yes.
Same question I had for the last guy. Who are your current customers with the government or military?
Certainly. We're developing this. Actually, Product 918 is an industrial design studio, and we developed this tool to keep our non-CAD using customers informed of our progress in product development. So we've partnered with UBT, who currently does two-dimensional assembly and training manuals to approach TARDEC. We've received pull from inside on this technology, and we're also, in the private sector, we're also working with some trucking and aviation companies to try and get this thing off the ground. All right, and then if we could go back to the PowerPoint, there's some contact information at the end. So we are a Michigan-based company. Sorry, these are all the things that I spoke through earlier, but contact information, feel free to photograph the screen and track us down for an on-site demo. We'd love to show you the telephone demo along with the Lego airplane you saw in the movie. Thank you for your time.